All right, guys, we are going to start subtracting linear expressions, which we've pretty much been doing anyway, but this has one little step, and we're actually going to be distributing a negative through some expressions before we combine them. So we've practiced combining like terms. We've practiced distributing by multiplying something through all the terms, right? We practiced adding linear expressions, which was really just like combining like terms, right? And now this just adds a little bit of a difference. So the first thing that they're showing us what to do is finding the additive inverse of expressions. Well, we talked about additive inverses when we were talking about opposite integers, right? If we combined it with that, it would make 0. So we said the additive inverse of 1 is what? No. What would I combine with 1 to make 0? Negative 1. I would say the additive inverse of negative 8 is 8, right? We don't have to write a plus there because we assume that it's positive unless we denote otherwise, right? So today we do have a little bit of variables, right? We've got variable terms within our expression. So what would you say the additive inverse of x would be? Fantastic. And the additive inverse of negative 4x is what? 4x. Do you see where we're going here? So if by chance we have a rational coefficient, meaning like a fraction in front of our letter, like 1/2 x, what would be the additive inverse of 1/2 x? Negative 1/2 x, because if we combined them, it would make 0. Okay, does that make sense about additive inverses? So here, to find the additive inverse of an expression, we can use the distributive property to multiply the expression by -1. So when we multiply by -1 or we divide by -1, we're just taking the opposite of that. So they're distributing -1 through here. Remember, our distributive property says whatever's touching my parentheses times one of the terms, whatever is touching my parentheses times the other term. And then we just need to do that. So what's -1 times 4? -4x. Remember our integer rules for multiplication and division. Negative times a negative is positive. But if our signs are different like they are here, it's negative when we're multiplying. And then what is -1 times 2? -2. And they did what I've been telling you to do. Instead of saying plus the opposite of 2, we're just going to subtract 2. They just kind of, that's what subtraction is. Subtraction is adding the opposite. So the definition of subtraction is really add the opposite. Okay, so that's what they use to get rid of that plus sign there. That's all. They're just telling you why they can do that. Sometimes they use big terms. All right, so you can check to see if 4x plus 2 and -4x minus 2 are additive inverses by adding them together to see if their sum is 0. So remember our magic squares. If we have 4x and we take 4x away, we have 0x. What's 0 times anything though? Just 0, right? And 2 minus 2 is also 0. So 0 plus 0 is still equal to 0. So because these two things have a sum of 0, they are additive inverses. So now, if I gave you an expression like 3x plus 4, what is the additive inverse of that expression? Yes, we're just taking the opposite of them. What if I gave you 7x minus 1? Yes, we're taking the opposite of both terms. So what about negative 8x plus 7? What's the opposite of negative 8? Yep, minus 7. So these are all additive inverses. If you wanted to label, if you've been taking notes, we can call these all additive inverses. Sometimes I feel like instead of all this gobbledygook, it just helps. Okay, we're just taking the opposite. We're just taking the opposite, right? That's 251. Any questions on this page yet? We're okay? All right, so I'm going to turn to page 252. That starts with example 1. So find the additive inverse of the expression. So what they're telling you to do is multiply everything by a negative 1. So they said negative 1 times 5 is this negative 5. They said negative 1 times negative 7 is this positive 7. All right. So most of you at this point now should be able to find the additive inverse of negative 7x plus 3. Go ahead and write in there for your check. We are just finding the opposite of these two terms, right? You're not doing this with us. This is not something you need to know any information. You can do this today without knowing anything. You have a decent attitude. All right, so we are going to use that opposite now to subtract linear expressions. We're on 252. So you took the opposite of negative 7x. What's the opposite of negative 7x? Positive 7x. And the opposite of positive 3, which is negative 3. So here's what we're doing. This, when we're subtracting and we have this parenthesis here, we assume that there is a 1 in front of it. So this is negative 1 times this. And negative 1 times that. So we have to rewrite the first and take the opposite of both of the terms inside these parentheses. Now, remember, I still have 8th graders that struggle with combining like terms. If our terms have a y in them, they can be combined because they're like terms. These are just constants. I cannot combine my y term with my constant. So here, they took the opposite. Do you guys see how they got this negative 3y and negative 4? They did the additive inverse there. So the opposite of 3y, they wrote it as negative 3y. The opposite of 4, they wrote it as negative 4. They just distributed that negative through the parentheses. So now we're looking at our columns and we are combining them. And the reason that they're in columns is because these constants are like terms and we can combine them. These variable terms are like terms and we can combine them. So 8y minus 3y is 5y, and negative 5 combined with negative 4, it's getting more negative, and that's where they got the negative 9. So example 2 is just kind of showing you with algebra tiles. So they modeled 6x plus 5, right? They drew out 1, 2, 3, 4, 5, 6 positive x's and 1, 2, 3, 4, 5 positive 1s. And then what you could do, probably what I would do, is subtract 3x's, so I would probably cross out 3x's, right? So I know I'm left with 3x's, but here, the opposite of negative 2 is actually positive 2, so I'd probably be adding 2 more 1's on. But they're showing you by finding the additive inverse. So they combined negative 3x's, so they did 1, 2, 3 of the negative x's, and they combined it with 2 1's. So these paired up and became 0, and you were left with 3x. That's where they got this 3x here. And 1, 2, 3, 4, 5, 6, 7 1's. Okay? So that is your algebra tile method. You are more than welcome to draw these out. Will it take a little bit more time? Absolutely. But if you're getting the right answer, it's absolutely okay. So they're distributing this negative through, right? Negative 1 times 3 is negative 3x. Negative 1 times negative 2. Remember, whatever sign is in front of that number sticks with that number. So negative 1 times negative 2 is positive 2. Then they're lining them up. So yesterday, when we were doing our homework, I was kind of showing you a shortcut. Instead of rewriting all of this, we were just kind of moving our variable term under our variable term and our constant under our constant. This was positive. And then we were combining them like this. So 6 minus 3, that's where they got the 3x, and 5 and 2 makes 7. So, in other words, here's our answer. 6x plus 5 minus the quantity of 3x minus 2 is equal to 3x plus 7. So try this check. You can distribute and write it. You can distribute and show it with your algebra tiles like they did for method 1. But you're really just multiplying through by a negative 1 here and then rewriting it. So you've got negative 3x plus 9. And then what is the additive inverse of that 8x minus 7? Those of you following along look like you're doing okay. So the opposite of 8x is negative 8x. The opposite of negative 7 is positive 7. So when we line it up this way, we can just add down our vertical columns here because these are like terms. The other way we were doing it is if we had it written out like this. Oops, plus 9. When we were just combining like terms, we were saying, all right, I've got a negative 3x and a negative 8x, and we were kind of moving them together. So what's negative 3 minus 8? It's getting more negative. What'd you get? Negative 11. That's our variable term, so we can't forget to include the x with it, right? So this was negative 11x. And here we're combining a 9 and a 7. They're both positive. So what's 9 plus 7? 16. What do I need between them? Since it's positive, I'm going to make a plus. Can I combine these and say 5x? No! Believe it or not, one of my 8th graders did that on their quiz today. No bueno. Don't do that. These are different terms. They're not like terms. We're going to be finishing up 5.3 today. We'll probably review on Monday, maybe Tuesday, but likely quiz on Tuesday or Wednesday next week. It'll just be on 5.1 through 5.3. So we haven't covered too much, but that 9 plus 7 was the 16. And to combine them as an expression, we need a plus in front of it. Okay? So hopefully you got that checked okay, or you're starting to catch on with us. So that's really it. Besides having to remember how to do fractions. Wah, wah, wah. So remember, this is like distributing a -1 through these parentheses. Oh, that's what they want us to do. They want us to add the inverse of them. So what is the additive inverse of this term right here? The positive 1/6x becomes what? Negative 1/6x. And the negative 3/8 becomes positive 3/8. So we have to get rid of these parentheses back here because there's a negative sign in front of them. If we were just adding them, it doesn't matter, right? But when we're subtracting them, we have to take the inverse of what is in those parentheses. Now, they're arranging like terms. So they took these and moved them over here. That's what this is. But then they had to find common denominators. So here, we're actually looking in our columns. We need the 3 to match the 6. So we multiplied them both by 2. So that's where they got this 4 on top and the 6 on the bottom. Those are equivalent fractions. And then we need this 2 to match the 8. So we had to multiply it by 4, which meant we also had to multiply the top by 4. So 1 times 4, that's where they got this 4 from. 4/8 is equivalent to 1/2. Then we're simply completing that, right? We have 4/6 minus 1/6. What's 4 minus 1? 4 minus 1 is 3. So we have 3/6x. And here we have 4 plus 3 is 7. So we have 7/8. Now we just have to simplify. We can't simplify the 7/8. That's as simplified as it gets. But what factor can I take out of the 3 and the 6? 3 is half of 6, right? So 1/2 x plus 7/8. Now, one thing I don't like is that they're not forcing you to write that x in there. They're just keeping it in there. And that is the thing that we forget to do the most, is to write the x after our variable term once we've combined our coefficients. Okay? So try that check. Find negative 1/6x plus 3/4, all minus the quantity of 1/2 x minus 1/8. So rewrite this, find the opposite of this, then find common denominators to add your variable terms together and then your constants together. up a little bit with the part that is new today, right? So I'm rewriting my first expression. And the second expression has this negative in front of it, and I need to distribute that by finding the opposite of both of the terms. Sometimes we might only find the opposite of the first term. Be sure you find the opposite of both of the terms. So hopefully you got to this point. And now we need to find common denominators here. So we're going to change this 2 to make it out of 6. We've got to change this 4 to make it out of the 8. We can only combine like terms. We can't combine a variable term, right? A term with an x in it with a constant, a term without a variable, or a lot of it can. All right, it looks like we got close. How do I make this 2 a 6? Gotta multiply it by 3, right? And how do I make this 4 and 8? I've got to multiply it by 2. Remember, whatever I do to the top, I have to do to the bottom. So this is like negative 1 6x plus 6 eighths. I said 3 times 2 is 6, 4 times 2 is 8. And then I have, this was negative 1/2, right? So this is going to be negative 3 6x plus 1/8. So my signs are the same for both of these, so I'm finding the sum 1 and 3 is 4, but it's a negative 4 6x. 6 plus 1 is 7/8, and it is positive. What do I need to do still? I gotta simplify. So I have to divide the top and the bottom of the 4 and the 6 by what? They're both even, so I can divide them by 2. So 4 divided by 2 and 6 divided by 2 keeps it equivalent. So I've got negative 2/3 x plus 7/8. Is that what you guys got? Can you figure out where you wrong if you didn't know it? No, I was trying to crack them open, but they really flew open. Okay, that's it, guys. For today, you're just finding the additive inverse and combining like terms still. So look here. The first 3 have you just finding the additive inverse. We practiced that before we even learned it. These 6 have you distributing the negatives here and combining them. These 3 just have you trying to figure out those fractions. And then you got a little test practice there on the bottom, okay? So I know you don't have a ton of time. We'll probably finish this on Monday. I will not be here on Monday. So I'll probably have you finish this Monday, and I may have another boom deck for you to add to your repertoire as far as practicing combining like terms or subtracting expressions. Yes, if you weren't here, you do have to go back and watch the videos, follow along with us. So I know when we're sick, sometimes we can't do a whole lot, but it does make it easier for your return if you try and do a little something. All right, so we're just working on page 257, 1 through 13 to practice this new bit here.